In this video, we are going to talk about definite integration. So you have already solved this integral. This integral is without limits. So if you are given this integral, you simply recall the power rule of integration and find the answer, which is x cubed by 3. But let's say now you have to solve this integral 1 to 2 x square dx. First of all, this 1 and 2, these are integration limits. So how do you read this? This is an integral where you have to integrate the function x square with respect to x, and x is running from 1 to 2. So this independent variable x, its lower limit is 1, its upper limit is 2. So 1 and 2 are called the integration limits. Precisely 1 is called the lower limit of integration and 2 is called the upper limit of integration. It simply means that x is in between 1 and 2. So we now have to solve an integral with the limits. So this kind of integral where you have the lower limit of integration and the upper limit of integration, this is called a definite integral. So you will solve the integral by recalling all the rules and methods of solving an integral, and finally once you have solved the integral, you will put in the limits. So you can solve the integral without the limits first. X square dx by power rule of integration is x cubed by 3. So your answer is x cubed by 3, but now you will apply the limit. Since 2 is the upper limit, so you will plug 2 in the places of x in this whole function, x cubed by 3. So in the place of x you will put 2 cubed by 3 minus, you will write the same function, but this time in the place of x you will put the lower limit. You will solve this. 8 by 3 minus 1 by 3, LCM gives you 8 minus 1 by 3, and your answer is 7 by 3. So this is the answer for the integral x square dx from 1 to 2. Just know that when you plug in the limits of integration, your answer is going to be some constant number. So this is how we solve definite integral. Definite integral is just the integral with the lower limit and the upper limit. And after you solve an integral, you will just put in the limits. Let's attempt another question. Let's solve this integral x dx with the limits minus 1 to 1. First, we will solve the integral x dx without the limits, which is x square by 2, again by power rule of integration. And now we will apply the limits, minus 1 to 1. So you write x square by 2, in the place of x you put 1 upper limit first, minus 1 in the place of x square by 2. Solve it. 1 by 2 minus 1 by 2 gives you 0. Let's attempt another question. You have to solve an integral 1 over square root 1 minus x square dx from the limits minus 1 by 2 to 1 by 2. First, we will solve this integral without the limits, which is 1 over square root 1 minus x square dx. We know that this is actually a formula which is sine inverse x. Now put in the limit, minus 1 by 2, upper limit 1 by 2. The function in the place of x we have the upper limit, minus the function in the place of x we have the lower limit. And we are done. Let's say we have to solve this integral. This is not a definite integral because we don't have the limits. So when you solve this by power rule of integration, you get x cubed by 3 plus some constant. But when we are solving a definite integral, in that case we don't put this constant c. This integral minus 1 to 1 x square dx, you simply solve this integral without c and then you put in the limits. Minus 1 to 1, it gives you 1 cube by 3 minus 1 cube by 3. It gives you 1 by 3 plus 1 by 3, which is 2 by 3. So the purpose of giving these two examples is to show that when there is a definite integral like this, you don't add a constant after finding the solution of the integral. But in an integral without limits, once you solve the integral, you put some constant in your answer. Let's solve another problem. We have to solve an integral secant square x dx from 0 to pi by 3. Pi is taken as 180. Now first we will solve this integral without the limits. Secant square x dx is actually a formula which is tan x. We have solved the integral. Now we will put in the limits 0 to pi by 3, 0 to pi by 3. So we have tan pi by 3 minus the same function but with the lower limit, tan 0. So since pi is 180, 180 by 3 is 60 minus tan 0. Tan 60 is square root 3, or you can find this value in calculator. Minus tan 0 is 0, so your final answer is square root 3. Just know that a definite integral or an integral with the lower limit and upper limit will always give you answer in the form of a number. Let's solve another integral 1 over x dx from e to 1. That is, the variable x is running from e to 1. E is called the lower limit of integral and 1 is called the upper limit of integral. First, we will solve this integral without the limits. 1 over x dx is ln x. And now we will apply the limits from e to 1. We have here e to 1. First plug in the upper limit, ln 1 minus now the lower limit in the place of x. ln 1, you will see that it is 0 and ln e is 1. So your final answer is minus 1. So this is how we solve definite integral questions. Just know that integral is solved by recalling all the rules and methods of integration, like integration by parts, integration by partial fractions, trigonometric substitution, simple substitution. But after solving the integral, you just have to finally put in the limits and your answer will be in the form of the number.